In the 17th century, mathematicians were trying to find the exact sum of the reciprocals of all perfect squares. 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus 1 over 25 plus till infinity. They knew it added up to something finite as it clearly doesn't grow to infinity, yet nobody could figure out the exact number. In 1734, a young Leonard Euler shocked the math world by proving the sum is exactly pi squared over 6. The grand mystery is, why pi? Pi is the ratio of a circle's circumference to its diameter. There are absolutely no circles in a list of squared whole numbers. To explain this visually without getting bogged down in Euler's original algebraic Taylor series proof, we can use a beautiful geometric proof popularized by mathematician Johan Wästlund. It relies on the inverse square law of physics. Imagine you are standing in the dark. If a light bulb is 1 meter away, it has a certain brightness. If it moves 2 meters away, it's not half as bright. It's 1/4 as bright. If it's 3 meters away, it's 1/9 as bright. Now imagine an infinitely long straight coastline. You are standing in the ocean, a little bit off the coast. On the coast, there are lighthouses spaced exactly 1 mile apart in both directions. The light from the first lighthouse hits you with an intensity of half. The second hits you with 1/4. The third with 1/9. The total brightness of all the lighthouses shining on you is exactly the sum of the Basel problem. To figure out the total brightness of this straight line of lighthouses, Wästlund's proof does a geometric trick. It replaces the straight line with a circle. Imagine you are standing at the edge of a circular pool. Instead of a straight line, the lighthouses are spaced evenly around the circular edge of the pool. Using basic geometry, it's surprisingly easy to calculate the exact total brightness of lighthouses arranged in a circle. Because you are calculating things on a circle, the math naturally involves pi. Here is the visual climax of the proof. What happens if you make the circular pool bigger and bigger, while keeping the lighthouses spaced 1 mile apart? As a circle's radius approaches infinity, the edge of the circle flattens out and becomes indistinguishable from a straight line, just like how the spherical Earth looks flat when you stand on it. If you take the algebraic formula for the brightness of the circular lighthouses, which has pi in it, and stretch the radius to infinity, the circle transforms into the straight coastline. The geometry of the circle vanishes, but the pi gets permanently left behind in the final equation, leaving you with pi squared over 6.